Okay, here we are testing again. Okay, today we are going to look at a new way to describe the location of this point. And normally we are used to describing it in an XY manner, and you see it looks like it's on a Cartesian plane that we're used to. So normally we would have, the X here and the Y here, and this point would be described as the point 4, 6. Well, today we're going to show you a new way to describe this point, and we're still going to, actually let me use a different color there. Let's use red. We're still going to have two elements, but the two elements are going to be a line and an angle. And the way that we do this is we take and we draw a line from the point to the origin, and we call that line R. And then what we do is we say, okay, we have our R, and that R goes here. It's our first element. And we say, okay, what angle, what size angle does that line R make with the x-axis? And here's the x-axis. And let's go back to my pencil. And what angle, what size angle does this line make with this x-axis? Well, we don't know what size it makes, but we're going to call the angle theta. So that theta is our second element then to our description. And we call this system where we use the line and the angle, we call that the polar coordinate system. And now what we're going to do today is we're going to find a way in which we can flip-flop between the two systems. So if we were given just the xy, we want to be able to describe that point in terms of r and theta. And if we were just given r and theta, we would like to describe that point in terms of x and y. So the way that we do that is we have to try and find relationships that we know from our past, formulas that we know from our past that incorporate both x, y, r, and theta in them. So the first thing that we would want to do is we want to, and let's change the color just, we would want to drop a line down from our point to the x-axis, and we would be making a right triangle there. So let's go back to our pencil, and doesn't really look like a right triangle, but this is our right triangle. And we know that there is a relationship between the sides of a right triangle and this long side that's opposite the 90. And if we were to try and name the sides of these triangles, for this example, we're going to use x for this side and y for this side. And the reason being is that this is the x-axis and this is, or I'm sorry, this is in an x direction, I should say, and this is in a y direction. So what kind of formula can we think of for a right triangle that involves two legs of the triangle and the hypotenuse? Well, you guessed it. It's the Pythagorean theorem. And normally it's a squared plus b squared equals c squared, but we're going to just use the elements that we have here. And I'm just going to go ahead and circle them all. So we have our x, we have our y, and we have our r. So the Pythagorean theorem then would be x squared plus y squared, that's our a and our b, equals r squared. And that would be our c. I'll just write it up here. This is what we're normally used to seeing. A squared plus b squared equals c squared. So, doesn't really look like a 2. Equals c squared. Okay, so now we're going to work with this x squared plus y squared equals r squared whenever we are given the x and y coordinates and they're asking us to convert to polar. However, we're missing the theta in this formula. So we need another formula. So we have to try and think of what other formulas or relationships do we know that involve our x, our y, and our theta of a right triangle. Well, let's try and remember our little mnemonic device, SOHCAHTOA. And of these three relationships, or ratios I should call them, which one involves the x, the y, and the theta? Well, that's the y is the opposite, the x is the adjacent. So here is the opposite and here is the adjacent. So yay, it's the tangent. So then we write tangent of theta equals, and tangent is opposite, which is our y, over our adjacent, which is our x. So there you have it. So now, whenever you are given an x and y coordinate, like a 4 and a 6, we can plug that in to this formula. The 6 would go here, the 4 would go there, and get our theta. And the 6 would go here, and the 4 would go there, and we would get our r, the length of our r. So these two formulas we would be using when we go from Cartesian to polar. Well, now we need to find some formulas to go from polar to Cartesian. Well, to go from polar to Cartesian, it's really better to have a formula that has just the y in it without the x, and vice versa, just the x in it without the y. Because remember, if we're going from polar to Cartesian, they're giving us the polar. So they're going to be giving us the theta and the r. So we want to try and find a relationship that we know. We'll just start with the y. We want to find a relationship that we know that involves theta, r, and the y. So let's see. We go back to our diagram. We got the theta. The r is the hypotenuse, and the y is the opposite. So let's try and think of a relationship that we know that involves the theta, of course, and the opposite and the hypotenuse. Well, we have the opposite here, but this is our x-coordinate, the adjacent. We don't want that. But here we have our opposite and our hypotenuse. So of course, it's the sine. So then we write sine of theta equals opposite, which is our y, over our hypotenuse, which is our r. And then we would further like to isolate the y, because remember, we're going to be given theta and r, and we want to convert it to the y coordinate. So we want to multiply both sides of the equation by r, and that gives us y equals r sine of theta. So that's great. So now we've got our y coordinate. But now we need to find another formula that involves just our x and our theta and our r. So the x again is the adjacent. We have theta, and then r is the hypotenuse. So you guessed it. Here's our adjacent, and here's our hypotenuse. So that's the cosine. So we write cosine of theta equals adjacent, which is our x, over our hypotenuse, which is our r. And once again, we will want to isolate the x because we're going to be given theta and r, and we want to know what x is. So we multiply both sides of the equation by r, and we end up with x equals r cosine of theta. So there you have it. We are going to go ahead and kind of circle or put a rectangle around the two that we really want from this group. So when we're going from polar to Cartesian, these two are kind of the two that we want. And then when we're going from Cartesian to polar, of course, then we will want these two. That was kind of sloppy. Let's try that one more time. Okay. So there you have it. So now in our next video, we will actually go ahead and solve some problems. We may even start with our 4 and our 6, and we'll just keep flip-flopping back and forth. Okay, thank you.